Hello everyone, welcome back to Binary Tree AI Machine Learning course. Um, Today we're back with lesson 5, which is Intro to Neural Networks. My name's Arvin and let's get started. So let's first think about what a neuron is. If you're familiar with the term, it's little cells in your brain that shoot little electrical impulses and help you think. Now, we know about biological neurons, but I'm going to show you about mathematical neurons. It'll look complicated, but do not worry because we will dissect them step by step in later slides. So let's keep this analogy in mind. Let's think about the fact that with these neurons, all these tiny little neurons, your brain is made up of them and helps you make day-to-day decisions, and it's the core like core capability is remarkable, complex, smart behavior. It's the core intuition behind how neural networks work. So this does look complicated, but basically all these small little things, this small individual example branches out into how huge neural networks can form complex thought, artificial intelligence, machine learning. So let's do a little example. We're going to use these features to predict home prices. So let's say x1 is size of home, x2 is number of bedrooms, x3 is rating of local schools, and x4 is repairs needed. We're going to make a single neuron network. So the function of this neural network is using these features, or on the input layer, we're going to feed them into a neuron, and then a price is going to be outputted, a prediction of how much the price of the home should be. Now, within this, we have to put weights. So going from each feature in the input layer to the neuron, we have to add a weight, which is basically a multiplier. We also have to have a bias term, which is just adding an extra weight in there. It's just kind of an additional constant, like in y equals mx plus b, that line equation. It's just that additional y-intercept. We always have to have this additional bias in case there is one. And then we sum all components up and output price. The way this works with real values is we take each value, so size of home, let's say is 1800, and we multiply it by its weight, which is 400. Same thing with bedrooms, which is 2 times 4500, 75 times 50 for rating of local schools, and -1 times 2000 for cost of repairs needed. And then we just have our bias term out there by itself. We sum all of these up together, and then we get our predicted price. This is what our machine learning model, our neural network, is predicting the price of the home should be based on all of these values. Now, one question is, why do we think the weight of the cost of repairs needed is negative? Is because if there's cost needed to fix the house, then that should subtract from the total weight of the total value of the house. Now, how are we actually getting all of these weights though? How did we figure out that cost of repairs needed should be negative? I did not tell the neural network that it should be negative, but it figured it out on its own. To keep things simple, let's imagine our data set is just one home, and our features are here that we said before. The actual price it sold for was $780,000. How to train the neural network? Let's begin. So step 1 is we just set weights randomly. We're going to set these random weights of -25, 80, 10, 120, and then a bias term of 4. I've just set these randomly. I didn't pick them, handpick them. They were just set from some random range, and we're just going to go ahead and do a forward pass to get a prediction using these weights. So we do our multiplication, addition, and get our prediction price of a predicted price of $195,000. That's a horrible prediction. Our actual home price was $780,000 and it came down to only $195,000. That is a terrible residual. We were off by almost $600,000. Now, when we think about that, in linear regression, remember, we tried to minimize this loss function. We wanted to make sure that the MSE, mean squared error, was as low as possible. Same thing with a neural network. We calculate the loss by comparing what is the prediction versus the actual. We check the loss, we get the residuals, and find the mean squared error, which is really, really bad. Now, what we do is we backpropagate to adjust the weights. So what we do is we go back and think, if I had increased this weight, So the negative 25 weight, maybe I would have had less error because the number for the expected price would have been a little bit higher. Maybe if I had lowered the weight for repairs, if I made it negative, maybe it would have lowered the MSE, the error. It would have made the prediction price higher, lowering the error. Now, we make those changes. And how do they actually get done? Let's not worry too much about that. But basically, long story short, we take calculus 3 concept, which is gradient, and we use the gradient to see where is, if we make a small change, if we make some sort of bump, and we call this the learning rate, if we make a small change in one of the weights, how does that affect our price? And does it make it better or worse? And we use calculus to find which changes make the error the smallest, and then we make those changes. Now, we repeat that process over and over again until we get a good accuracy. So we go ahead and do the pass prediction, forward pass prediction, calculate loss, and then we backpropagate, changing the values and repeating. So we can repeat again and again and again until our prediction is good. And there we are. That is how a trained neural network works with learned weights. The more you keep passing through and retraining it, doing more and more prediction, or doing more and more pass-throughs, backpropagating, we could get better and better predictions. Do we think that this single neuron will give highly accurate predictions for all homes? Not necessarily, because homes have so many more factors to them than just one single neuron. We can't just necessarily combine all these factors into one and expect it to get us the price every time, which is why we need to build more complex networks. So for many small things, small dumb things, which is one small neuron, we can build an entire brain, an entire network with multiple layers and multiple neurons, more than just one. So you can remember there's something called deep learning, which will take many neurons and put them into several columns or layers for more complex mappings of inputs to outputs. And if our neural network has more than one hidden layer, we update those weights layer-wise. So the backpropagation works just the same. It works backwards layer by layer. So it'll work for each layer, one by one, going from each neuron. So this neuron back to the layer, then the next neuron back to the layer, and then it goes to the next layer, going neuron by neuron, adjusting the weights as we see fit. So that was our overall explanation of neural networks. How do they work? How do we train them? What do they do? Next, we'll talk about tuning these actual neural networks and using them for classification problems, not just quantity-wise.